Welcome to the Short Span Steel Bridge Alliance's 2020 topic-based video series. In this series, we'll review basic concepts and ideas pertinent not only to engineers new to short span steel bridge design, but those looking for a refresher of fundamental concepts. In this video, we'll review 5 frequently asked questions about short span steel bridges. Since the Short Span Steel Bridge Alliance's creation in 2007, the Bridge Technology Center has traveled all across the country and given multiple presentations at engineering conferences, at local technical assistance programs, training seminars, design firms, etc. Collected in this presentation are 5 of the most frequently asked questions that we've received over the years, as well as the associated responses. To begin, question number 1. Which is more economical, steel or concrete? No matter what, throughout the years, as we've made these presentations, we will invariably get asked at some point, which is more expensive, steel or concrete? And the short answer is that it depends on the given project. To give you an example, the table that you see here is taken from a case study that was performed in Audrain County, Missouri. More details about this case study can be found at the Short Span Steel Bridge Alliance website. This table summarizes some of the cost data from the county engineer in Audrain County. This was the money spent at the end of the day on a series of projects built in Audrain County for bridges in the short span range. Summarized at the bottom is the construction cost per square foot, which is essentially the bridge cost per square foot minus some site-specific issues such as rock and earthwork. As you can see, dependent upon the project, sometimes steel options are more cost competitive, sometimes concrete options are more competitive. For instance, there are steel options that present cost per square foot of $80 or $74.68. Whereas if you look at concrete solutions, there are some that present $90 and a comparable steel solution presents $100 per square foot. It depends from project to project, but in no way, shape, or form is one option always cheaper than the other. It depends from project to project. So as an engineer or as an owner agency, you should consider both options and always go with the one that's most economical. Question 2. Aren't steel bridges more complicated than concrete bridges? The short answer is no. While geometrically complex steel bridges, such as skewed bridges or curved bridges, can present very distinct challenges, if we're talking about a routine project, a short span steel bridge doesn't need to be any more complex than a comparable concrete solution. By utilizing commonly available steel products and employing simple and repetitive fabrication details, an efficient short span steel bridge design is definitely within your grasp as an engineer. And with tools such as eSpan 140, you can complete a preliminary design of a short span steel bridge in under 5 minutes. You can then take that design and tweak it and refine it for your specific project. Question 3. How does steel versus concrete perform over their design lives? It's very common that we'll get asked that maybe one solution is more cost competitive versus the other initially, but what about over their life cycle? There was a very interesting study done by Michael Barker at the University of Wyoming where he collected a series of design data points for a matrix of bridges in Pennsylvania and computed their probability that they would last over 75 years, the AASHTO LRFD design life, and plotted this for a series of typical solutions. And as you can see, there's really no instance where one bridge or one option is going to perform appreciably better than the other. In summary, you'll find that with proper fabrication practices and proper engineering, you'll find that these solutions are very comparable throughout their design lives. And there's a wealth of information in this report, and I urge you to review it for more details. Question 4. What is a typical span to depth ratio for short span steel bridges? A very common question that we'll get asked is about the overall superstructure depth for a given project, and that is very critical to many state and county engineers due to clearance issues and hydraulic opening requirements. Now, span to depth ratios can vary from project to project, but a good rule of thumb is that the L over D ratio should be somewhere around 25 to 35 for girder type bridges. In general, the fewer the beam lines, the deeper the sections, and that can change dependent upon your jurisdiction. Some jurisdictions have mandated cross sections that's going to govern the design. So you should always refer to your state and local guidelines for more details. Now, this guidance is specifically focused on looking at typical rolled beam or plate girder solutions. There are other options to combat strict depth restrictions, such as the manufacturer solutions found on the short span website, or some more innovative solutions such as press brake form tub girders, which are designed to be shallow in situations with strict clearance requirements. And the final question is, where do I start? Throughout our experience, we found that most engineers simply aren't as trained in short span steel bridge design as they are with concrete solutions. So the Short Span Steel Bridge Alliance has provided a wealth of resources for you as the engineer to begin using short span steel bridges in your projects. The first resource that I think is worth mentioning is eSpan 140. I've mentioned this earlier in this presentation, but it is a very valuable tool to begin a short span bridge project. It generates a preliminary design. It stores the previous projects that you've input, so you can refer back to those in later work. And it also provides a wealth of contacts of association members, fabricators, service centers, producers, all of the cogs that form the bridge delivery engine. You'll find contacts for that within eSpan 140, so it's a great place to get started. There's also a wealth of information on the Short Span Steel Bridge Alliance website. There's more information on manufacturer solutions, coating options, etc. And there's a wealth of technical resources on short span steel bridge design, all freely available to anybody who accesses it. Very worthwhile resource. This concludes this video from the Short Span Steel Bridge Alliance's topic-based video series. We hope you found this video informative, and we look forward to you joining us in the next video. Thank you for your time.